Hello and Assalamualaikum to our panelists and viewer to my video presentation. This video is in purpose to present my final year project MEC601 with project title Investigation of Tribological Behavior for Graphene Composite Coating using Finite Element Method FEN Effect of Test Loop. My name is Abdul Aziz bin Jusoh and I will be the presenter of the video. My supervisor is Dr. Roselina Binti Roseley. Please enjoy the video. Project Summary. Graphene is the material for use in the 21st century. In this paper, the effect of test load for nickel graphene composite coating is investigated through a linear finite element method to see the tribological behavior. ANSYS mechanical is used to calculate tribological parameters such as contact pressure, frictional tension, and wear thickness using the Arcade well model. The result of tribological properties will be validated with the past experimental work. Introduction. The background study for this project are focusing on tribology, coating, graphene, and finite element method FEM. Tribology is an analysis of friction, wear, and lubrication on moving surface. Tribology can contribute the energy efficiency cost of industry. Tribology also can help by study to reduce the friction, for example, creating a layer of coating. Next, coating is the process forming and applying thin liquid to solid surface. Coating flows include those used in coating process, as well as those that occur after coating and before immobilization. Coating are one of first line of protection, as well as the final line of defense in reducing the likelihood and effect of different damage process on equipment, process pipe, and pipelines. Furthermore, graphene is the smallest and strongest material in this world. At the same time, graphene has own outstanding mechanical characteristics such as unit structure and electrothermal properties. Since then, graphene has gotten a lot of interest in the world of materials. It can be used instead of silicon to create a solar cell, photonic sensor, and nano antimicrobial material, and it can also be utilized to fabricate supercomputers, which have a wide range of applications. Graphene is a two-dimensional hexagonal lattice made up of a single layer of densely packed carbon atom. Lastly, finite element method or FEN is used for numerical solving include traditional field of structure analysis, heat transfer, fluid flow, and mass transport. In this work, finite element method will be used to analyze wear rate of nickel graphene composite coating with a test load. Literature review of the project. Number 1. Is nickel graphene composite coating. Graphene is often said to be the strongest material ever, with an inherent strength of 130 gigapascal and a Young modulus of 1 terapascal. Graphene has also been reported to be theoretically impenetrable to all molecules and iron, making it an excellent corrosion barrier. Number of votes has been carried out on using graphene as the reinforcement addition for composite material production. It has been demonstrated that polymetric graphene composite has increased mechanical strength and electrical conductivity. Nickel has excellent and long-term fatigue resistance, mild stiffness, and lower thermal expansion coefficient. Nanoparticles in composite coating have previously been proven to improve the steel hardness, corrosion resistance, lubrication, and anti-friction characteristics. The distribution of the graphene in the nickel matrix may be uniform, which improve the mechanical characteristic of nickel composite. Mechanical properties of nickel graphene. As the quantity of graphene in the composite coating rises, the vehicle's micro-hardness of the coating increases, as shown at the figure top right corner. The quantity of graphene can affect the micro-hardness of the material. From figure bottom left, the graph shows the difference micro-hardness between pure nickel with nickel graphene. The improvement in durability with graphene concentration increasing. The graphene extreme high mechanical strength may have contributed to the composite coating increased hardness as shown in figure bottom right. The tribological properties of nickel graphene. The coefficient of friction, or we call COF, has been reduced to approximately 0.1 when using nickel graphene coating as shown in the figure bottom left. There is a big difference COF between pure nickel and nickel graphene. Pure nickel has higher COF than nickel graphene. Low COF can reduce more friction between a moving surface. For the figure bottom right show the friction coefficient with different amount of graphene. The friction coefficient of uncoated friction pair is about 0.88, while the friction coefficient of coating with different amount of graphene 0.1%, 0.2% and 0.4% are 0.82, 0.868 and 0.61 respectively, which are 8%, 23% and 31% lower than friction coefficient of uncoated friction pair. Numerical analysis of tribological behavior of coating. The three-dimensional model was built to account for tribological behavior. There were several difficulties that could not be addressed in this model or earlier model to replicate the real contact environment. Krishnamurti et al. Successfully report the result of zirconia composite coating by using numerical analysis as shown in the figure below. Problem statement of the project. There are several factors influence the tribological performance of material, such as coefficient of friction, contact between surface, contact pressure, contact temperature, frictional force, and others. Several studies has been carried out to identify the influencing parameter and their impact on overall tribological performance with and without coating. Objectives of the project. To overcome the problem, ANSYS is used to predict the tribological properties of nickel graphene composite coating and must follow these objectives. Number 1. To develop a finite element analysis FEA of nickel graphene composite coating. Number 2. To assess the effect of the type of load numerical using ANSYS FEA modeling of nickel graphene composite coating on contact pressure, frictional stress, and wear thickness. Scope and limitation of the project. This research will focus on tribology properties if nickel graphene composite coating will be testing on several loads, and this software will be used for modeling and simulation. The scope of the project are follows. First, geometry modeling on pin and disc. Second, test load will vary between 5 Newton, 10 Newton, and 15 Newton. Third, the parameters of the model and finite element are based on the experimental result from Toysenzat et al. The limitation for this project is there may be limitation of the computer primary memory and the mesh size of the student version of ANSYS software. The methodology of project. Figure shows the flowchart of the simulation using ANSYS for this paper. ANSYS workbench was used to build a three-dimensional model for the pin on this tribometer. Aluminum oxide as a disc with diameter 135 mm and nickel graphene as a composite coating for three-dimensional model. The most critical stage is FEA simulation is machine, which influences the time required for convergence and the correctness of the result. By adjusting the parameter of the element, the model is optimized for solution convergence. Table 1 shows the summarize the experimental parameter used for pin on this tribometer. The sliding velocity, sliding distance, coating thickness, speed of this will be fixed at 0.1 meter per second, 300 meter and 50 mu-meter and respectively. The load applied on the pin will be varied from 5 Newton, 10 Newton and 50 Newton. The tribological characteristic, friction coefficient and wear rate are calculated from Toishniz et al. Using the experimental conditions specified in Table 1, while the outcomes are reported in Table 2. ANSYS Mechanical was used to solve and analyze tribological features such as sliding status, contact pressure, penetration, friction stress, and wear characteristics under continuous sliding motion (CSM) of nickel graphene coating over aluminum alloy. The preliminary work of the project. Figures below show the three-dimensional model to run the analysis using the ANSYS mechanical simulation. The diameter of this is 135 mm, while the diameter of pin is 12 mm.
Expected result for the project. We expect to see the coefficient of friction and wear rate of various load 5 Newton, 10 Newton and 15 Newton. The result should be different between the various load. Coefficient of friction for load 5 Newton will be more higher than 10 Newton and 15 Newton because of the low pressure load applied.
That's all from me for the research final year project. If there are any questions regarding to this video, please don't hesitate to drop a message or email. Thank you for your time.